Hello again. Today we're going to talk about solving quadratic equations. And so when we get into quadratic equations, remember a quadratic equation is an equation that can be written in the form of ax squared plus bx plus c equal to 0, where of course a is not 0, otherwise it wouldn't be a quadratic then. I'm going to talk to you in this section about four ways to solve them: factoring, square root property, completing the square, and a quadratic formula. Now, my video when I discussed polynomials has already discussed solving these types of equations by factoring. So this first portion will probably be just a review, but here we're just focusing only on quadratic equations. So here I have 4x squared minus 19x minus 5 equal to 0. And you might remember that if a product is 0, then either the first factor must be 0 or the second factor must be 0. So if we factor this into 4x plus 1 and x minus 5. So that means either the 4x plus 1 must equal 0 or the x minus 5 must equal 0. So we're going to get two solutions. On this 4x plus 1 equals 0, all you have to do is subtract 1 from both sides, then divide both sides by 4, and you'll get x equal negative 1/4. And on x minus 5 equals 0, all you have to do is add 5 to both sides, and you'll get x equal 5. On this next one here, we have 4a squared minus 81 equal to 0. And this actually factors as difference of squares. So it factors into 2a plus 9 times 2a minus 9 equals 0. And then if you set 2a plus 9 equals 0 and solve it, you just subtract 9 from both sides, then divide both sides by 2, and you get a is negative 9/2. On this one, you can add 9 to both sides, then divide by 2, and you get a equal positive 9/2. This one could also be solved by the second technique, the square root property, but we'll get to that later. Alright, so this one is 5y squared minus 35y equals 0. Here we have a common factor that can be factored out. Notice there's no c term, so we can factor out the 5y. And if we factor out 5y, we get 5y times y minus 7 equals 0. And then just set 5y equal to 0 and set it y minus 7 equals 0. And then here, if you divide both sides by 5, you get y equals 0. And here, if you if you add 7 to both sides, you're going to get y equals 7. Okay, so this next property that the next problem we're going to look at, this one is not in the standard form yet. So the first thing I've got to do is I've got to get this problem into the standard form for a quadratic equation. Ax squared plus bx plus c equals 0. So what I'm going to do first, I'm going to distribute this x through this parentheses. X times x is x squared. X times minus 1 is minus x. Then I'm going to distribute over here. 3 times x is 3x. 3 times 15 is 45. Okay, now I'm going to subtract 3x from both sides. And if I subtract 3x from the right-hand side, it'll just cancel the 3x. And of course, if you subtract 3x from minus x, it'll give you the minus 4x. And then the other thing I'm going to do is subtract 45 from both sides, and that'll cancel this 45. And since there's no constant on this side, we'll basically just subtract 45 from 0, and that'll give me minus 45 on the left. Now I have it in standard form, and I can factor this polynomial here into x minus 9 and x plus 5, and then if you set the x minus 9 equal to 0, you can just add 9 to both sides and get x equal 9, and then set x plus 5 equal to 0 and subtract 5 from both sides and get x equal negative 5. And so there's your answers for that. Okay, let's go ahead and also talk about using the square root theorem here. The square root theorem is used when you have a squared quantity equal to a constant. So like if you have x squared equal to b, where b is some constant, then to get x, all you would do is just apply the square root theorem, and so x would equal plus or minus the square root of b. Now, that expression that's squared it doesn't have to just be x. It actually can be an expression squared. So here I have x minus 3 quantity squared equals 64. And then when you apply the square root theorem, that tells me that x minus 3 is equal to plus or minus the square root of 64. That's just applying the square root theorem. And then the square root of 64 is 8, so we have x minus 3 is equal to plus or minus 8. And then if you add 3 to both sides, you get x equals 3 plus or minus 8. And 3 plus 8 would be 11, and 3 minus 8 would be negative 5. So there's your two solutions there. Now, for this theorem to work, you've got to have the squared quantity isolated. So what I'm going to do is subtract here 20 from both sides. So subtract 20 from both sides here. And so minus 80 minus 20 is negative 100. And of course 20 minus 20 just cancels it. And that isolates the squared quantity. Okay, now if I apply the square root theorem, then this would be x minus 4 is equal to plus or minus the square root of negative 100. Now, if your course does not talk about complex numbers, you can actually skip this one and just do 1 and 3. But some courses don't cover complex numbers. I should say some intermediate algebra courses don't cover complex numbers. But this is actually, when you take the square root of negative 100, that's actually going to be plus or minus 10i. And again, if you don't understand this because your course doesn't cover that, then just skip this problem. So anyway, that would be x minus 4 is equal to plus or minus 10i. And then you add 4 to both sides, and you get x equals 4 plus or minus 10i. So there's two answers here, 4 plus 10i and 4 minus 10i. On the third one here, you actually want to add 16 to both sides first. So if you add 16 here, it'll just cancel the 16s. And then if you add 16 here, it will give you 96. So that way you'll have just 3 times x plus 7 quantity squared equals 96. Well, then the next step, you want to get rid of this 3, so just divide both sides by 3. And when you divide both sides by 3 on the left, it's going to cancel the 3's. And then dividing both sides by 3 on the right, it's going to give you 32. So we have x plus 7 quantity squared equals 32. Well, now that we've got the squared term isolated, we can apply the square root property. So apply the square root property to both sides, and you get x plus 7 is equal to plus or minus the square root of 32. Now, we talked earlier about how to simplify a radical like square root of 32. You just write that as the square root of 16 times 2, and then you can take the square root of 16 out, which is going to be 4. So this is going to equal plus or minus 4 times the square root of 2. And then since you have x plus 7 equal to plus or minus 4 square root of 2, now just subtract 7 from both sides, and you get x equals minus 7 plus or minus 4 square root of 2. So again, that's two answers. It's minus 7 plus 4 square root of 2 and minus 7 minus 4 square root of 2. Now, if this was a word problem and you needed a decimal approximation for the answers, you could actually put this in your calculator and you'd figure out what minus 7 plus 4 square root of 2 equals, and that would be one answer, and then figure out what minus 7 minus 4 square root of 2 equals, and that would be your other answer. And so that completes the lecture here on solving quadratic equations by factoring up here and also the square root property. And so the next video I'm going to talk about completing the square and also the quadratic formula.